All right, we are live. Good morning, everyone, or good afternoon, or good evening. It's morning for me. So, if you watched yesterday's stream, you'll know that I was struggling with a bunch of matrix math to transform a flat image into some kind of projected 3D space. And I said I was going to go and do some revision of matrix math and then come back. So that was yesterday. Unfortunately, I only got to do about 30 minutes as my daughter, who's only 2 years old, was crying a lot. So I had to be with her last night. And and I'm still sick, so couldn't really stay up too late. Feeling quite under the weather. But in those 30 minutes, I think I had those 30 minutes plus Gustavo came to me in a dream, which was quite interesting. Gustavo is the man who runs Picuma.com. And I have got one of his courses actually, this man. So he teaches fundamental game programming, assembly, graphics, and stuff like that. And he's focused on the math a lot, I believe. I think he is a mathematician, if I remember correctly, or at least he's a professor. And yeah, he came to me in a dream, kind of. It was a bit weird, but I haven't finished his course, but there was one part I remember where I think he was doing something similar, and we had to find an angle from the viewing point on the plane, on the near plane. And the way that you would do that is actually to do two tangent calculations. So if we have a look at, we'll just grab a box here. I think this is right. I mean, it was in my sleep, so maybe I'm wrong, but I'm going to verify it shortly. If you imagine, okay, we need to find a point up here. Okay, and we've got the rays, they're shooting straight through the middle. So the middle one is directly straight, right? That makes sense, because we're looking from front on, we're looking straight through the middle of the screen. So if we have that midpoint, and we have this point here, well, we can sort of do let's say this is the midpoint, and then this is the point we're trying to find. We can translate this midpoint across to here, and then we have to find this well, we have this distance, which is tan, right? So we have to find the angle. So we have the position, actually. We need to find the angle. So to find this, as long as this distance is 1, then... Oh, do I have to do arctangent for this? Damn. See, my sleeping brain was not ready. But the other part of this puzzle is yesterday I was trying to transform something from clip space into world space or view space. I think into view space. But anyway, either way, I was using the view and the projection matrix, which were multiplied in the order to go from local space up to screen space eventually. And you can't just use the same multiplied matrix in reverse because it's actually wrong. So you've got to reverse the order of the matrices for that to have any effect. So we're going to see if we can get something going here. So I basically got this shader. It's pretty much the same as what we were using yesterday, I think. But I want to see if we can get the ray direction from a particular pixel. So if we choose, for example, maybe we should simplify this actually. So we need to make a function that can get the direction from our viewing angle towards the pixel that we're looking at, right? Yeah. Okay. So let's see. This page is not going to help us with that. So this is linear algebra. It's going to be Pythagoras theorem, I guess. And that's going to give us the length. We already know. We already know the length. We need to know the angle. I think it's a tan 2 for this. Am I crazy? The angle between positive x-axis from the right. Okay, I'm going to look at a different answer here. So a tan 2. Maybe we'll look at MDN. Yeah, so it gives us theta based on the position that we pass in. So yeah, we just want to use this, I'm pretty sure. But that's going to give us along the x and the y point. So that's going to be on one axis, right? So we need to do both axes, I suppose. So we can get the angle up and then the angle left in this case from the middle. So the angle up is going to be just a tan 2 and then this y needs to be the y, but x would be 0, I guess. No. I gotta look at the image again, 1 second. Okay. So we've got to look at it from a different angle. Let's have a look. So, whoops. All right. So if we look at it from the side, you can imagine this is the plane that we're looking at. And we want to find this point, but we can't see how far on the x-axis it is, and it doesn't actually matter for our purposes, I think. So what we can do is we can say this is going to be a right triangle here. Over to our viewing plane. Actually, we could probably even do... No, we can't do that. So we've got to find the midpoint. So we're finding one near the top, and a midpoint, let's say it's about there. Oops. Okay, so we want to find this angle here. It's a really fat line. There we go. Usually called theta. And we can do that with a tan 2. So we just put this coordinate in and we get this angle. So that gives us how far up the ray is going to be rotated. Then we need to know how far to the side it's going to be rotated. So we can do exactly the same thing. And in fact, if you imagine that this point, we're actually looking down from the top now, and this is on the left of the screen, and this is the middle of the screen, or the center, and we have the exact same calculation, just on a different axis. And then we need to rotate the point by those two angles. So let's see if we can find the angles first. I'm sure GLSL would have a tan 2, right? There's probably a better way to do this as well. This is just the way that came to my mind while I was sleeping. Wait, what? Okay, apparently there is one. It's called a tan. So if we look at the, I guess we'd say this is the pitch, and it's an angle, and we put in the Y position and the X position of the pixel, and then the, what would that be, yaw? Hang on a second. No, we don't want to put in the Y position, the X position of the pixel. We want to put in, X is going to be 1, I guess. So actually it would be the distance from the camera to the plane, which I'm going to say should be 1. Let's just say this is 1. I don't know if that's going to be accurate for our other camera though, so we'll see. So this will be 1 here. Okay, and then yaw would be, if we're looking from above now, then looking from above, then this would be Y again? No. Hang on a second. I feel like I need to do a little bit more of an extreme example to just get my head around it in case, because they're kind of, I was kind of in the corner, so it's a little bit similar. But if we did something like over here, this pixel, then so I noticed in maths and algorithms in programming, if you have cases that are too similar to each other, you can end up with a result that looks correct because they were too similar. But it doesn't work for everything else. All right. So we'll just draw the X here. I will draw it from the top. So you can imagine we're looking down here. Okay, we're finding the angle between the view distance, which we'll say is 1. So this is going to be 1. And then the pixel is sort of over here. So we're going to find this angle. So that's for the x-axis. And for the y-axis, which is how far up it is, I'll say we're viewing from the side. This is going to be 1. And how far up are we? Something like this. Okay. So in our x-axis, atan 2, we want to pass in an x of, well, see, now it's rotated, so I'm confused. I'm going to rotate it back. Wait. Well, it'll be an x of 1 and a y. And then this is also an x of 1 and a y, which is why I'm confused. Does that make sense? I guess they're heading in the same direction. Yeah. Yeah, I suppose so. They're both going in that direction. Okay. So they're both x of 1, but this is going to use the y coordinate and this is going to use the x coordinate. X and 1. And the reason I'm putting them in the opposite order is because, well, usually atan has y first and then x. And I mean, it's confusing because we're using x here, but yeah, the order's backwards from what you would usually expect for a function that deals with an x and a y coordinate. Okay. Well, I think we've got pitch and yaw, but how would I test that? Hmm. Um, I can just write a little, maybe a little JavaScript or something in here. So if we've got a screen, 1920 by 1080 is going to be the size of the plane that we're using. Actually, let's use an easier number. Let's say it's a square and it's 100 pixels by 100 pixels. Or maybe 100 pixels by 160 pixels or something. So 160 wide, just so that we don't get weird results. Width is 160. I can't use const. Okay, whatever. Oh yeah, is there even types in JavaScript? No. Height equals 100. I programmed JavaScript for like 10 years. I was trying to use a float. I just know that all the numbers are doubles, so it's fine. What's next? So we've got the width and the height, and we've got our point, which is going to be, let's say, -1. So viewing point. Hey David, how you doing? David says var name type equals value. For numbers, type is number. Yeah, the number type is just a double though, isn't it? Viewing angle, viewing position is, do we even have, we don't have vectors. I'm pretty sure there's no vector in JavaScript yet. No. All right, viewing X, 0. Viewing Y is 0. Viewing Z is -1. What just happened? Okay. That's cool. Now, let's see. We basically want to do the same thing we just did here. So we got coordinates that we want to find. We want to find the pitch and the yaw. So, if we are looking at this 100 pixel screen from 1 away, I have a feeling there's something missing here. But anyway, let's see. So pitch is math.802, and it's going to be, what was it again? Y and X. Yeah, of course. So let's say we're going to look for, well, let's try the middle first. So we'll try 160 divided by 2. No, that's the width. 100 divided by 2 and 160 divided by 2. That gives us 0.558. Yada, yada, yada. Is that right? What's pi divided by 4? That's an interesting number. Yeah, this is not correct, is it? Oh, I did the wrong value in the second thing. It should be 1. 1.55. 1.57 is pi divided by 2. Well, what am I missing here? I don't know. Is there a linear algebra? I think there is probably, right? Linear algebra. I don't know. Explorer, playground, or something. Desmos. What is this? Okay. Okay. I don't actually want to do a transformation. And so this is a calculator website. Right. I don't know exactly. Graphing, I guess. Okay. What do I do with this? Okay, so this is just graphing. How do I, is there functions? Function expression, okay. Alright, I don't know what this is. Let's see. Getting started. Alright, so you can just make... Okay, that's kind of useful actually, but not for what we're doing right now. What is this? Matrix playground, matrix visualizations. Oh, actually, let me just go to here, because they explain everything in this page, I think. So we've got vectors, yes, length, dot product, cross product, matrices, scaling, rotation, combining. Oh, they don't actually talk about what we're doing. Okay. Let's look at radians explained. Yeah, full circle is 2 pi radians. 1 radian is 57 degrees. Wait a second. This should return radians, right? It does, okay. Between the positive x-axis and the ray from 0, 0 to the point x, y. Okay. So I would have expected a different number. Why? Maybe I'm just thinking about it wrong. Oh yeah, of course, I'm stupid. So yeah, it doesn't know the center point is 55. So we actually should put 0 in here. Yeah, I'm being stupid. Good. So we're looking right at the center. It's actually 0. So if we want to go up, I think it would be positive direction up. Let's see, can we test that? So if we go up to the full height would be 50, and we get an angle of 1.5 radians. And can I multiply, what do I multiply that by to get degrees? Times by 180 divided by pi, okay. No, I didn't have to do that. almost 90 degrees, which sort of makes sense because if you think about what we're doing right now, it's not this. It's more like if this is 100 pixels tall, we're sort of doing this. So we're only 1 unit back. So yeah, I feel like we're missing something in this step because 1 unit in our world is sort of like 1 meter, but then we're talking about pixels straight away. I did find a solution that kind of works. Let me see if I can find it here. But it also doesn't completely work. I'm not 100% sure of the reason, but we look for this. One's right back. Find angle between view and neoplane pixel. Right. Yeah, let me put this on the screen. I was looking at Stack Overflow. I think the question is a little bit different, but what's HO? HC. The height of the camera. Distance from the ground? Yeah, so this is not what I want. I want... I guess perspective projection. It's not important where on the neoplane the projection intersects the neoplane. What matters is where in relation to the viewport they are projected. Try to add points representing the corners/edges of the viewport and you'll see that px and y always projects in the same relative spot, independent of d. Okay. The FOV is 90.2, the aspect ratio is 1:1. What if I want to allow for other FOVs and aspect ratios? Also the perspective transform the frustum into a cuboid. Okay, there's a lot of questions there. Maybe the best thing to do would be to actually work through this. Where is it? Is it this? Coordinate systems? Because it does go through the projection, right? Yeah, field of view is this angle. Okay. See, this is sort of just telling me how to use the... I mean, it does go over the theory here, actually. Let's see if we can derive some solution from this. So clip space is where we are now. With our ray marching thing. I can't remember what the value of this was, but yeah. So all the visible coordinates will be within the range -1 to 1. We specify our own coordinate set to work in and convert those back to NDC as OpenGL expects them. Yeah. So to transform the vertex coordinates from view to clip space, we define a projection matrix that specifies a range of coordinates. In each dimension, the projection matrix then converts coordinates within the specified range to NDC. So we want to do the reverse of that, which means we got to inverse the projection matrix, I guess. Okay. Let's see. Well, I think I gotta undo a lot of stuff in this shader. Actually, this kind of worked, I think. And I'll show you what I mean by kind of. Wait, was that the right? No, that's not right. Was it this one that kind of worked? Yeah, I think so. Alright, so there's the 3 spheres. But something really weird is going on here. So if we go down, we get closer to the spheres, they start warping. As you can kind of see. Right, and then if we go really far down, they're going to warp into infinity. Or like, repeat. Which is very strange. And not really what we want. And so I was just trying to figure out the problem, but actually we're inversing the view projection matrix here. I'm pretty sure we can't just do that. Yeah. Alright, so first thing I'm going to do is I'm going to separate them. I'm feeling worse than yesterday. It's not good. So the model is always 0. I'm going to just not use that. At the moment, I'm going to just change this to... view and projection separately. So I'm going to make a SDF push constants here. It's kind of annoying that push constants can only fit 2 matrices, but that's alright, I guess. Okay, no, I'm gonna swap the order. View and projection like this. Okay, so VP is not a thing anymore. So I'm gonna inverse the... Which one is it? I think it's the projection that I want to inverse first. No, it was here. This page. Projection. Yeah, so I'm gonna try this. Wait, that's not gonna do what I think. Now I can't move the camera. Whoops. Hmm. Well, that's an interesting result. Hello, Golden Lion. Yeah, I have a couple of games in mind. First one is going to be a horror game. I think that's the plan. So that actually did work much better. What the hell? It's driving me crazy. I'm gonna need a proper, solid couple of nights of study, I think. Maybe I should move on to something else. We can worry about this a bit later. So, let's see. Oh crap. The cube pipeline is not drawing cubes anymore. What's going on with that? You're making a game using Raylib and Odin. It's kind of an engine, coding features as I need them. That's cool. What are you working on? I'm confused as to why the cubes are not drawing anymore. We're making dungeon dice monsters from Yu-Gi-Oh! Okay, that sounds interesting. I don't know what that is. I mean, I vaguely remember Yu-Gi-Oh! From when I was a child. It's like a card anime or something, right? You make it different enough / experiment with rule changes? Yeah, that sounds good. Why are we not seeing cubes? They had a few episodes where they played a game different than the card game, like a dungeon dice monsters. Right, okay. I'm not updating the buffer anymore, I guess. Oh no, here it is. The fast compile times in hot reload and Odin are so nice. Yeah, I had hot reloading working earlier, but well, I have to figure out how to make it work with Vulkan, and I just haven't bothered yet because the compile times are so quick. Hasn't really bothered me yet. We should be seeing cubes. Why are we not seeing cubes? Okay. Here it is. We've got the descriptor set. We'll begin rendering. Oh, I can just check render doc. Render doc will tell me some information, hopefully. It would be this one, right? So the UBO is full of densities, yeah. Yeah, I made it myself, but I did look at Carl's. Mine is a bit different though. His system is kind of complicated. Not that that's a bad thing. I just think it handles more things than I needed. Mine's more similar to Handmade Hero. Okay, I don't understand what the problem is. So we got the stuff that we need in the vertex shader, and the fragment shader is just not drawing it. Oh, we're discarding everything. Yeah, okay. I knew I was gonna get bitten by that. Okay, there we go. Okay, cool. We got our cubes back. That's good. So maybe we will in fact go down the left side of this path that I outlined yesterday. Where was it? Here. So I wanted to go down this path because I haven't done this stuff before, but I need to do some more study. So I think I'm going to go down this path, doing like multi-threading, terrain sculpting, and things first. And then I'll go down this path after. So, okay, let's think about this. We're drawing one chunk. We need to encapsulate this functionality somehow. So right now, the cube uniform buffer that we're updating is just happening here. Where is it? Here it is. Yeah, so what are they? 32 by 32, I think? Or 16? 16 by 16 by 16 chunks right now. So we want something like chunk generate and chunk load. Take some coordinates, I guess. Maybe vec3i. Chunk. So this would also take coordinates, I guess. These are kind of the same thing. Not really. Depends. I guess load would check if there's already changes. We don't need to do that yet. So we'll just do generate. Actually, we'll just call it load and unload. Okay, so we're going to load and unload chunks. And that should be fine. I guess we'll just work on load first. Hmm. Okay. Chunk loading. Here's the thing. We need somewhere to put these things. We've got density values, which currently we're just using to see if something is air or rock, or air or solid. I'm gonna make this white. We also need somewhere to put the vertices. No, actually we're using our shader generates the vertices. We don't have to worry about that. Okay, so actually all we need is somewhere to put the densities, which means we need a uniform per chunk. Or a storage buffer. Usually what I would do in OpenGL is I would just make a VBO per chunk, and then they would just load their own VBO kind of deal. Yeah, so all we need actually is somewhere to put, how many is it? 4,096 floats per chunk. That's fine. But when we load a chunk, I guess we could use, let me look at the pipeline. So if we think about the pipeline that we got here, which is going to be the cube pipeline, right now, it just renders one chunk, but this could actually just be a loop of, let's see, if we got the descriptor set, cube descriptor set, right? Which is saying which uniform buffers are currently bound. How slow is it to update descriptor sets? I have no idea. Can we time this, I guess? I don't know how accurate this is going to be. Just want to see, 5.5, is that nanoseconds? Microseconds. Yeah, not very long. If that's the case, can we update descriptor sets on the fly? Like, could I call this, for example? I'll just copy this code here. We'll go down to here and we'll say update descriptor sets. Oh, did I miss something? No, that's fine. Okay. And if I call that every frame, what happens? We go to an error here saying so descriptor set was created with descriptor binding flag 0, but this descriptor set is in use by the command buffer. The destination set member of each element or descriptor copies for bindings which are created without the binding update after bind bit. Right. Cannot be used. Okay. Alright, so I think if I go to here, descriptor pool, descriptor set count is 1. Wait, what? This is not the point cloud pipeline, this is the cube pipeline. That's what I get for copying all my code. Alright, so we've got the descriptor set. What other options do we have? Destination binding. Buffer view, no. Actually, I'll just ask Google. Can we dynamically update descriptor sets in Vulkan? Okay. Dynamic descriptor sets. Yeah, okay. I feel like there's a lot of context missing for me. Alright, here's a question. Okay. In Vulkan, when we update a descriptor set, this means that we specify handles of resources that should be used through the given descriptor set. Okay. Well, unfortunately, that's not the question that I need answered. It is possible to avoid using that flag by updating descriptor sets instead of deleting them. Uh-huh. Recycled descriptor sets, huh? So basically the thing that I want to do here is I want to update the descriptor set to use a different buffer and then run another draw command. Right? Where is the code that I'm looking for? Down here. Here. So my thinking is, at some point, we may be able to do that, but it looks like there needs to be a flag set, so this is just going to fail again. So it says that the descriptor set, when we call update descriptor sets, the destination binding 0 was created with descriptor binding flags 0, but this other descriptor set that already exists is in use by the current command buffer. The destination set member of each element of descriptor writes or descriptor copies for bindings which were created without the binding update after bind bit. See, I want to find where this is. Or update while unused, while pending. Okay. Must not be used by any command that was recorded with the command buffer, which is in the pending state. Okay. Gotcha. Okay, let's look up this. Oh no. Oh no, this website's okay. This website's okay. VK descriptor binding bit flag is used when we create the descriptor set layout. Binding flags create info. Which is descriptor set layout create info. Okay. Right. So that would be This one, right? No, apparently not. Descriptor set, layout, binding, create info. So this is a... Yeah, I didn't think it was in here. This is just the stage flags. Where the hell is it? So I'm looking for this. Binding count. So VK descriptor set layout binding flags create info. Right, but where do we use it? Is it in the descriptor? Right, okay, we need to use it in the pnext flag of descriptor set layout create info, which is this one. Okay, apparently I don't get any auto completion though. So if I try to build this, is it going to fail? No? Okay. That's alright. Well, what are the flags? P binding flags, okay. And then I need this type, descriptor binding flags. And I guess this might actually be a different type here. Let's have a look. It's descriptor binding flags. Okay, so yeah, it's a bit field. I want update after bind, I think. I don't know if that's actually what I want. I'm gonna try it though. I'm not sure if this is gonna compile. Okay, apparently that's all correct. We'll see. Not correct. Created without the bit, were they? Doesn't look like it to me. Oh, I didn't put the type in. Okay, what else? Binding count 1, I guess. Is that right? I'm not sure. Because the binding is actually 2. Actually got 2 of them. So, a bit confused about that. I'm guessing it's referring to this though. So yeah, still getting the same error, so this is not actually fixing our problem. I'm going to make it into a separate struct. That will do. Flags. It's not exactly the best name, but anyway. Hey Mochu, how you doing? Binding. For some reason my eyes keep straining. Do I wear glasses for far viewing? I don't. I do have a very, very slight short-sightedness. I think that's what it's called. It's like 0.25. Binding count 1 is different from this binding count 2. Yeah, okay. So it should be 2. Well, that's a much better error. Okay. So this looks like we got the same error again. Is it the same or is it different? Let's see. Update descriptor sets. Yeah, was created with unhandled descriptor binding flag bits. Unhandled. Descriptor binding flag bits unhandled. Okay, yeah. Alright, how many times are we going to say that? Cool. So, oh, it's telling me the bits, I guess. Unhandled, unhandled. Okay. And it keeps going. But this descriptor set is in use. I don't understand the problem. Update after bind. Have I synced the ray marching eye with the camera? No. I tried to do that this morning, but I'm still missing too many pieces. I only got about 30 minutes of study in last night on matrices. So I had an idea. Well, I had a couple of ideas about finding the direction of this ray for each pixel, which I think makes sense. So you'd use ATAN2 basically on both axes, and then combine the pitch and the yaw to find the angle. But the other thing I realized is, where is it? The space we're looking at now, I think it's clip space, right? And so we got to convert back to view space. I think. Or are we in view space and we got to convert back to world space? Well, either way, we've got to do the inverse of one of these matrices to get back. Yeah, I found some solutions that sort of work, but since I can't really understand them, I can't really modify them to make them work better. So I'll show you real quick. Where's the code? I think I commented it out, yeah. Oh yeah, yeah. So you can see here, it looks like it's working, right? Looks great, yeah. But then if we go close to these orbs, you'll see something a bit weird. Uh-oh. Uh-oh. Ooh. Yeah, and so since I don't understand well enough the math to do the projection or the reprojection, I don't want to just struggle learning matrix math on the stream. I think that's a little bit lame. So I decided to work on chunk rendering instead. Or like chunk creation, creating multiple chunks. Now that I think about it, there's no reason we have to have separate buffers. We could just use one large storage buffer, I think. You can increase it to whatever you want. The maximum size for storage buffers is quite big. Okay. How big is that? As big as the VRAM can fit. Okay, great. So I think what we're going to do is something like this. I'm going to make a... God, excuse me. Basically, all we need to store is these density values, and then our vertex shader takes care of everything else, right? Actually, no, that's not correct. Damn. The vertex shader is designed to draw one chunk at a time. That's what this math here is for. The instance index. No, that's fine actually. We can just draw different instances. That should be okay. Okay. Should be fine. Similar things happened to you in raster while just trying to use quaternion for camera. It was so confusing that now you use a vec3 to represent Euler angles. And I think you shouldn't gimbal lock, hopefully. Yeah, hopefully not. Just don't do roll. I think you're okay if you don't do roll most of the time. If you can help it. Yeah, okay, I got an idea about this. See, this stuff, I'm much better at this kind of stuff, which is memory management. You're not doing a flying plane game, so you're okay? No, that's good. Alright, so for this, we need to store a bunch of density values, so I'm thinking, imagine this is 4098 density values, right? Which is what we're storing for our chunks. And at the moment we've just got one buffer that stores one, but we could store just a series of these in a large storage buffer, and then we draw the instances. Oh yeah, did I do 8? Yeah, 4096, you're right. Yes. I even deleted the 6 and put an 8. So 4096 F32s. And then we'll say we've got 4 instances in this case. So then in our vertex buffer, we can say that our index into the densities is going to be the instance index divided by 4. Oh no, hang on a second. Oh, we're doing instanced. Well, damn. I realize that might be a problem. Okay. Well, I'll figure it out. We should be able to still do this anyway. So basically we just want to offset it by whatever chunk we're currently rendering. And we could do that in a couple of different ways. But first we need to make sure that we're not making uniform buffers anymore. So cube uniform buffer, we're gonna just get rid of this and make it a cube uniform buffer. Make it a storage buffer. We need to make a storage buffer with, I think, different privileges. So it's going to be storage buffer, sharing mode, that's fine. I don't think I need that. Yeah, exclusive is okay. Is that really all we have to do? I thought we had to set read and write privileges somewhere. Or is that for the memory? So it's going to be host visible, host coherent. That's right. Uniform buffer 2. I guess this is also a storage buffer. Actually, we'll keep one uniform buffer on the cube. That will be for just whatever various data we might need to pass in. The cube shader, I should say. So this one is storage buffer. And the cube storage buffer size, let's just say we're going to do, right now, we'll just render 2 chunks first as a test. Okay, that should be fine, I think. We don't need to time this anymore. We'll get rid of this update descriptor sets here. Now, cube storage buffer. It's going to be updated here, so we're going to send in 1 chunk and then another chunk. So I'm just going to copy this code. And I'm going to say that the X, Y, and the Z are going to be, maybe the X can be plus 16. Yeah, that should be fine, I think. Cool. There's a lot of code in this file now. Okay, let's see. Build, and it's gonna fail because we didn't update the fragment shader yet. The vertex shader rather. So let's do that now. This is the storage buffer, I guess. And I think it's called storage. No? What is it called? Oh yeah, read-only buffer. Yeah, that's right. So this is actually going to be read-only buffer. Okay, I don't know if it restricts us to using vec4s. Yeah, I'll just pretend that it does. So this can stay the same. That's all good. Okay, so now we should be able to draw... Where was it? I'm gonna draw ×2. Actually, now that I think about it, this... Yeah, okay. This is not gonna work, but I want to see how it's gonna be broken. No, it did work. Wow. Okay, that's good. I always think there's going to be something broken. Alright, so we've got 2 chunks rendering next to each other, and I didn't have to do anything crazy. That's weird, we still got this validation error though. Shit. Excuse my French, sorry. Storage buffer. Expected type storage buffer, but got type uniform buffer in the graphics pipeline create. Gotcha. Yeah, here we go. So that would be in what? somewhere in here. Where is it? Huh. What am I missing? Missing something. Do my adjacent cubes share vertices or have their own at the same position? I think they share vertices right now. Because it's using triangle strip to make them. I'm not 100% sure how it works. 14 vertices. Yeah, maybe not. Maybe they all have their own, actually. Yeah, that makes sense. It's still less than 36, which is the usual for a cube. So we've got a storage buffer, yeah. And a uniform buffer, right. But apparently I must not have set that somewhere. Oh, here it is. I'm starting to see some patterns that we can perhaps abstract. Like, for example, I have to set the buffers here. And I've also got to set the buffers here. Descriptor set layout and descriptor and right descriptor set, you know? Seems like they could be turned into a function or something. Why did my build fail? Weird. Alright, cool. 2 chunks working. Oh, we still got an error. Descriptor set layout, binding flags, create info, contains flag. That's not recognized? Oh. Right, yeah, because I added all that stuff. I'm just going to delete that. That should be fine. Okay, no errors now. Cool, so we got 2 chunks. Good. Let's see if we can make more than 2. So we got... Where are all the chunk stuff? Chunks. So obviously we can't just have chunk total multiplied by some random number here, but I'm going to do that for now. So point cloud, that's not what we're doing this. I'm going to try 8 chunks. I don't see why it would be any different. The only thing is we need to update the uniform. Where is it? Sorry, the storage buffer. Where is it? No? Here it is. So that's going to be the second chunk, and then we can do... Oh, man, I don't want to do it like this. Let's do another loop here. For... How do I want to do this? I guess I'll do it like this. So we're just going to have them all on 1, 2, 3, 4, 5, 6, 7, 8. Yeah. I'm going to do it like this. For CY. Obviously this is not a final. This is not going to be the final code. So CY is going to be 2, 4, 3. 1, 2, 3, 4, 5, 6, 7, 8. Right. So this is going to be 1. This is going to be 2. This is going to be 1. And then we just basically take this. What do I like about Odin that Rust, Zig, C don't have? I would say that question is a little bit misleading because doesn't have most things that those other languages do have. And I would say Rust and Zig have too many things that I don't want. And C just doesn't quite have enough things that I do want. So Odin is the middle ground. Yeah, I guess so. It's very simple. I mean, that's maybe a bit of an overstatement. It's pretty simple, but it's still quite powerful. And it doesn't have annoying things in it, I think. I don't think anything in this language annoys me. So it's really about reducing friction. So I want programming to be fun. I don't want it to be a pain in the butt to get things to happen. Does this work? No. Chunk width. Times. Depth. Okay, I think that should be good. We'll see. No, it looks like I just made them on top of each other. Or what? This is crazy. What happened? Storage size, yeah, times 8. Good. Yeah, we're doing it. I must have messed something up here, obviously. Let's have a look at the data in the buffers. Okay, this one I think it is. So we've got the push constants, the storage buffer. It's got 131,072 bytes. Oh. After the first... Am I on Linux or Windows? I'm on Windows. I've used Linux a lot. I've used Linux for many years. But unfortunately, Linux doesn't have as good programs as Windows, so... For game development, anyway. Hang on a second. 4,096. So 2,048 times 4 is 8,192, whatever, right? That's not enough values. So that's enough values for 2 chunks. Not enough values for 4. For 8 rather. So something is wrong in the creation of the buffer, I think. Not that one. My editor, this editor is called Helix. Huh. 8 times chunk depth, chunk height, chunk width. What's the problem with that? Oh, hang on a second. 1, 2. This should be equals to. No, that's not a. it should be like this, not less than or equal to. It should be just equals. Okay, there we go. I apparently got this. Wait a second. What? Oh yeah, the vertex shader doesn't take the chunk position into account. I mean, it kind of does, but not exactly. So what we need to do is maybe pass in, or we can probably, yeah, probably pass in a value, but I need to be right back. I'll be just a minute. Hey guys, how you doing? The BRP scene is like a stock anime scene from Stream Elements, so I'm surprised that it's actually such high quality. But it's also kind of like using it's kind of like using, I don't know, stock anything really. There's going to be a million other people using it. I don't really care though. Hey Chad, how you doing? Hey Alex. um, so the problem that we just had was our chunks have no world position offset. It's just kind of working because of the way we set up the indices. Sorry, essentially this, because we didn't mod this by the chunk depth, so it just keeps going back, right, on the z-axis. So if we actually did mod chunk depth here, then I think we would get all of them stacked on top of each other. Am I right? Yeah. So that's cool. That's fine. So what we really want is to get a world position for each chunk. And I suppose we can get that by, well, I guess we just send them in. That's probably the easiest way. So we've got a storage buffer. It's got way more than 1024 densities actually. It's got some unknown number. Yeah, I'm surprised there wasn't Z fighting as well actually. But I guess there's no textures. So I don't know. They should still be different colors though, because they've got different density values and that's, yeah. But anyway, what we can add in the uniform, I suppose, is a list of chunk positions, perhaps. So I don't know how many we're going to allow, but you know, right now we'll just say we got 8. And this is going to be the world offset for each chunk. So when we use this crazy for loop here, and we iterate, we generate the noise, we also want to map into, not the point cloud buffer, we want to also get another pointer here, which is going to be uniform data, I guess. I don't know. Okay, we're just going to say it points to vec4s. And I guess we'll say it's kind of annoying. So chunk index, I guess. So it's going to be 0. I'm going to just say uniform data chunk index. Wait, hang on. What is the data? It's camera position and chunk positions. We're currently not using the camera position, so I'm just going to delete it. Chunk index equals chunk positions. Yeah, right. So we'll say vec4, chunk x, chunk y, chunk z, and just 0, I suppose. These have to be converted to float 32s, of course. Okay, and then we've got to increment chunk index here. Yeah, this is just to make sure we can make this all work. Now we apparently have chunk positions, right? So if we mod the hang on a sec, let me think about this. So every 1028 density values is going to be related to one chunk. So that means that the world position is going to be chunk positions and then instance index divided by 1028. Whoops, 1024, sorry. This has to be an int. I think that already will be an int. I have a feeling I'm missing something here. That's alright. So now we say the actual position is going to be world pos plus position. This needs to be multiplied by the chunk size. I guess actually we should send in that value from the CPU. Okay, hopefully that works. That did not work. Oh, right, this is the wrong thing. This needs to be uniform buffer, not storage buffer. Okay, let's just make sure that the uniform buffer memory is set up properly. It's definitely not. So we need to set up, I guess, what would it be, 8 vec4s right now, because that's the amount of chunks we're rendering. And something is wrong. Alright, that's fine. Let's have a look at render doc. Hey, what happened? Oh, render doc is crashing. Huh. It's interesting because the game isn't crashing. Well, I suppose running it again is not going to change anything. Let's just see. Oops. Is there something wrong with this shader? Yes. Array must be redeclared with the size before being indexed with a variable. Oh, okay. That's interesting. So we've got to say how many we're putting in there. But for some reason we don't have to do that with the storage buffer. Huh. Also, this is called camera, but it's not really. Okay. Yeah, that's actually looking good. We just forgot to use a factor of the size of a chunk, I guess. CX. Yeah, I plan on making 2 games with this engine, at least. First game is going to be a horror game. Second game is going to be a very, very big game that's going to take me many years. So, kind of like the best way to describe it would just be to describe other games put together. Minecraft crossed with, well, not really Minecraft. Actually, yeah, kind of Minecraft crossed with Kensei. Kenshi, sorry, not Kensei. But not blocky. So I'm only making blocks right now because it's simple. Yeah, the offset is wrong because this needs to be world position times. I mean, I thought we were sending in the correct world chunk position. So this is going to be 16. 0, 16, etc., but no. Let me just look at the data in here. I can't. Alright, something is seriously wrong. Okay, could it be... that's 8,196, isn't it? Could that be a problem? Maybe the render doc doesn't like? I wish it would tell me something. Just crashes. Huh. Will I do everything solo? Dev, audio, art? Yeah, probably. I do have a friend who is a music producer, so maybe we'll team up, but we'll see. He's also really into graphics programming as well, so that's cool. What is going on here? So we're drawing chunk total times 8, 14 vertices. That's all good, I think. It's gonna be something silly again, isn't it? But the only thing we're really messing with is the memory for the uniform buffer and the chunk. Let's see, 1, 2, 3. Sorry, 1, 2, 3, 4, 5, 6, 7. Right. So it'll actually be 2 times 3 times 2. Oh. Wait, hang on a second. 1, 2, 3, 1, 2, 3, 4. Ah, this is too many. Yeah, that's better. Cool. I don't know if this is correct. It looks wrong to me. Like, that's too flat. It's kind of interesting. Can I launch it in here now? Yes. Yeah. Okay. So let's have a look. We've got the storage buffer. let's look at the chunk positions. Yeah, 0, 0, that's cool. And then we go to 16 on the Z axis first, and then 16 on the Y, and then I think the order might be wrong. Yeah, okay. So that's correct, except maybe the order is incorrect. Maybe we do them backwards. Because I think we want to go X, Z, no, X, Y, Z. So this is going Z, Y, X. So I think we want to go Z, X. No, the other way. What's the problem? Oh. No, that's not correct either. One, two, three, 4, 5, 6, 7, 8. I mean, we're drawing the right amount of chunks. Actually, if I go to the debug pipeline, I might be able to do something with this. Debug uniform buffer. Where is it? Yeah. Alright, so we've got lights and stuff. That's all cool. What if we want to draw debug shape as F32? Oh, I can't scale them, can I? Oh, that's something I need to add. A scale. A way to scale them. That's fine. So it would be data 4 is equal to... I guess I could just put this in the previous line. Right, we're going to draw a circle cube, I mean not a circle, a yellow cube at each chunk position, which I guess I need to calculate again, which is a bit annoying actually. Where is that? What the? Where's this? Oh, it's just before the loop? Right. Okay, I think that should be okay. So we should get a yellow cube at each chunk position. Yeah. I'm going to turn off the depth buffer. So actually, yeah, it looks like we're rendering the chunks in the right spot and everything, but I'm pretty sure they're not in the right order because they're not matching up. And also this one is too much stuff, this first one. It shouldn't be this dense. Let's have a look at the vertex shader again, eh? So we've got the world position here, and all I did was offset the world position. Yeah, this should be fine, right? Unless this is wrong. Instance index divided by 1024. There's 1024 instances of a vec4 per chunk. Right? I'm pretty sure there is. 16 times 16 times 16. It's 4096. But they're vec4s, so that's why divided by 4, 1024. Okay. I mean, they could be just be weird noise. Let's have a look. Noise. Here it is. Calculating the noise by using the chunk position plus the X. Yeah, that's correct. Did I just disconnect or something? Stream Elements just said I'm online. Okay, let me see. Why do I plus 1 divided by 2? Oh, to normalize it to between 0 and 1. That looks right. That looks right. And that looks right as well. So this is going to be 0 plus x on the first iteration, right? And then this will be 0 plus x, etc., etc. So I don't really... no, the order's going to be wrong, isn't it? Did the stream crash? I think it might have, but I didn't see anything on my end. Let me just make sure that YouTube is still up. Yeah, it's still live, that's alright. Okay, we're very close to drawing multiple chunks. It's just the order, I think, that's wrong. Does that actually change anything? I don't know. I think that's different. Also, it still looks like every chunk is being drawn at the 0 position as well, which I'm a bit confused about. We're drawing 8 chunks. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Which is this many blocks. If I cancel this again, I just want to look at the chunks in a row. Oh, I need to actually get rid of this as well. So they'll be all in a row now. They look quite different. Yeah, they're definitely not being rendered properly. Which is interesting. So there's something wrong here. What is it? Cube vertices, that's all fine, right? Mod by 14, that's all good. It's gotta be this. Do I divide by 1024? Do I divide by and then mod 8 perhaps? what did I change? I forgot about this chunk depth. No, that's not gonna work. So the world position. No, that doesn't make sense. Okay, obviously this doesn't make sense. I didn't even try to do any of the numbers. So let's say the index is like, how many indices are we drawing? We're drawing chunk total times 8, which is not, that's a lot. So we could be drawing index 2000 divided by 1024 is going to give us 1.9. Yeah. So that would mean it's in chunk 1, I guess. So 4096. Yesterday I mentioned that Twitch chat should be on screen. Yeah. Oh, I didn't fix that yet, sorry. 4096 divided by 1024 is 4. That's wrong. We need to divide it by 4 again. I think that's the problem. I don't think it matters which order I do that in. Okay, is that looking better or what? That's looking much better. Okay, great. I think that's right. It might still be wrong. It looks like maybe it's still a little bit incorrect. There's a bot that sends all other chats to a chat, so for multi-streaming it's great. Yeah, I've got that. I'll show you. Hang on a second. You mean this, right? But I can't put it on. I guess I could put it on the screen if I add. Hang on a second. Let me add something. I'll add a window capture. Is that a separate window? No one from YouTube has been talking for a while. Oh. That's interesting. Let's see. What am I looking for here? Something in OBS? No, I can't find it here. I think I got to use something else. I'm not sure. I will figure it out how to get the text on the screen. Yeah, this crashed because OBS tried to inject a hook into it. I'm pretty sure. I'm not sure about you, but I feel like this is still a little bit wrong. Like, this is a very flat edge. So is my intuition about doing these backwards correct? Or was it incorrect? I think it's still wrong. Did I compile this? I'm using 3D Perlin. I am using whatever came in Odin, which I think is simplex noise. So it's, where is it? Here. It's, yeah, 3D Open Simplex 2 from the Odin standard library. Whoops. This looks a bit better, but I mean, it's definitely got flat on the right sides now. However, I think it's still wrong. I should add some lighting so it's a little bit easier to tell what's going on here. Can I do that easily? Cube.frag. We've got densities. We don't have any other information. But use fragment depth. I'm not sure what you mean. Like this. That did not compile. Oh, there is no, what am I doing? There's no XYZ. So it would just be a value between 0 and 1. That's an interesting result. What the hell? I don't think you can access the depth buffer like this. I think you've got to use an actual depth buffer. I'm not 100% sure though. Maybe you can. I might have just done it wrong. So writing to the depth buffer, GL depth. Huh. Frag depth, right. Right. So I think we can use frag coord Z, maybe? Right. That might be a very large number. Depth is enabled, so I'm not sure what the problem is with that. Does Vulkan tell me anything? No. Can you use normalize on a scalar? You can also swizzle the ZZZ for a vec3. Oh, that's nice. Thanks. Yeah, right, of course. I don't know if that works. What if I d equals d 0.4? Is that right? No, it's, I'm missing something here. Power diff I guess I'll try that. No, that's just very bright. What if I invert it? Equals 1 divided by d. Is it not building? It is. Okay, this is just not working as I expected. That's alright then. Oh, it still might be 1. Yeah, that's fine. We shall use the density, that's fine. That's right, I'll add something to it in a bit. I just want to, I'm pretty sure these are not in the right order. See, like there's that flat wall coming up, and then this little gap here. It doesn't look like what I would expect 3D noise to look like. So it's got to be because of this, right? So do we do... Shit. I'm just going to try the different configurations. Okay, it's not this one. So it's not X, Z, Y. I will try X, Y, Z. Why not? That looks the same. I don't think it's X, Y, Z either. Okay, then we want... I'm just going to stop arranging these. So X, Z, Y, and X, Y, Z. Okay, that's fine. We'll try Y, X, Z. That doesn't look different. That's interesting. Does the order of these not matter? And I'm actually got an error somewhere else. Is once again not different. Is this building? It is. Okay. I will try the last two combinations, but I don't think it's going to have an effect. Z. And if I think about it, it shouldn't have an effect. But something was changing, right? Was that crazy? I thought I saw something change. No, it's the same. Okay, let's stop doing that. So we're setting the world position here based on these numbers, which means we're using this chunk index. Okay. Oh yeah, of course it wouldn't change because we're using CX, CY, and CZ in here. So what actually is the problem? Seems like we're just drawing it in the wrong position. Right? We're definitely drawing the chunks. We're drawing the chunks in the right position, but we're drawing the wrong chunks in those positions. I'm pretty sure. Let's just change the noise a little bit here. What does that give us? Okay. Yeah. So I would expect, based on these, that this one would be maybe over there. This one would stay in the same place. This one would be over there. Or something like that. Definitely not like this though. This one is really dense, which is possible. That looks right. That looks right. That looks right. Maybe it was just the generation that looked a little bit off. And actually it was correct the whole time. Maybe a larger sample size real quick before I head off. So I'll make it 4 times larger, I guess. No, that's not 4 times larger. So that's going to be 2, 2, 2, 2. So we need 8 by 8 by 8 now. So where have we got this? 8 times 8 times 8. Flat parts were just a coincidence? Yeah, maybe. It's possible. I think that's all we need to do. Oh, we need to change this. 512 is 8 by 8 by 8, right? Oh. We don't have enough space. Okay. I need to make it less dense. So that would be bringing this number down. Yeah, this looks wrong. This looks fine, I think. This doesn't look fine. Yeah, this is definitely wrong. Definitely incorrect. Alright, good to know. Still creating kind of interesting stuff, but not what we want. This is totally wrong. Kind of confused as to how there's so many flat parts. Shouldn't really look like that. Okay. Well, I'm going to leave that for another time, but I will say at least we got a lot of chunks rendering. My far plane is definitely not far enough. As you can see, they're dissolving. So let's just move that. Should be on the perspective matrix. Perspective. So it's 100. We'll just make it 1000 for now. Seems like they're on some grid borders. Maybe I'm sampling the noise with the wrong offset. So there's discontinuities. Yeah, that is possible, isn't it? Like that looks correct. Like these two are joining together up here. Right? Maybe not exactly. Maybe that's a coincidence. I don't know. That definitely looks right. I don't know. I'll figure it out. Yeah, I'm sure it'll be something silly as usual. Like, if we look at the noise here, this should give us the world position, right? So chunk x times chunk width plus x. That's right. Chunk y times chunk height plus y. That's right, yep. And this should also be correct. So I don't know what the problem is exactly. Well, maybe this is a problem. I don't think so. Multiplying it by frequency, that should be fine. Alright, well, I'll do some experimentation offline tonight. I've got to go to work now. With that far of a draw distance, would you eventually need some sort of occlusion culling? For voxels, there's a bunch of different techniques. For example, you can use, well, you would merge the meshes into large planes or large, just larger meshes. So where you've got, I'll just open up this again. So let's say the terrain did look like this, and you're looking at something like this. You would find all of the squares, all of the cubes that are sort of adjacent, and you would turn that into one big mesh, so like one big rectangle, and all the ones you can see on the surface, you would mesh, and then yeah, underneath you would definitely cull them, and then further away ones you can do level of detail calculations. I haven't really done any of that stuff myself, but I'm not doing an outdoor game, so I don't really have to worry about that. It's actually one of the reasons I'm doing an indoor game. I am going to do occlusion culling. It's going to be a bit different though. So in the game that I'm working on, we've got like, let's say we've got caves. This is just some bad drawings, but some caves, maybe some like caverns, whatever. That looks a little bit funny, doesn't it? And maybe there's like some rooms as well that are carved out. It also doesn't look great. But anyway, let's say the player's standing over here. What you would do is you would fire a ray from, I guess, you would have sort of a portal or a doorway into this room, which you could, I guess, specify somehow. And then you would fire a ray from here. Which I think you could do it from the player's position, but you could do it from inside this room. So all the way from the corner down this hallway and see what you can hit. And then all the way from this corner down this hallway in a line. I'll just use the line tool. And like, let's say these are 3 different rooms here. So there's a room here, a room here, actually 4 different rooms, let's say. Something like that. So these are all different rooms. 1, 2, 3, 4. Because from here you can see this room, then you would load the data in this room as well. But you wouldn't need to load the data in this room because you can't see it. But then as soon as you leave this room, you do the same calculation from here, from this exit, and you would be able to see into this room. So therefore, you would load this one and then any ones you could see. But if there was another room like up here, let's say, like, Is there a limit to how many rays you should/could cast? Well, in this example that I'm showing, it's from, I think it's from Quake originally. The original Quake. And they just used, I think, one ray from each side of the door, or maybe from top, bottom, left, and right, something like that. You wouldn't need to cast a lot of them, I think, unless you've got really weird shaped doors. Like, for example, most doors are going to be squares, or some kind of rectangle, or maybe a cuboid. Not a cuboid, what are they called? Rhombus or something? This shape. Yeah, this. It's been a long time since geometry class. Something like this. But you don't usually get doors like. Depends on, yeah, on your game design and everything. But if you had a door like this shape, which might be in a sci-fi setting, right? Then you'd probably want to cast rays from these corners, like from here, and then from here, and here, and here. Trapezoid. Yeah, okay. Thank you. Yeah, because that way you kind of cover everything. So if you can see it from here, or here, or here, or here, or here, here, then you can see it from anywhere, basically. So that's one thing that I'm going to look into for culling interior zones. I'm going to delete this. It looks like a very unfortunate appendage. So just get rid of that. Okay. Great. I think I'm gonna have to call it there. I've got work to do. I'm kind of the poor appendage. Yeah. Deleted. Sad. Yeah, I'm gonna look at this later tonight after work. But I want to thank you guys for tuning in, and hopefully next time I will have studied enough. Wait, next time is tomorrow. So I'm going to study tonight. I'm going to study more maths and see if we can get the reprojection working. I might try to get it working offline and then just show how it's done and explain it, but we'll see. Because it really depends on what happens with my daughter. I might not have time. So yeah, anyway, see you guys.